Nano-Tera is a nationwide Swiss research program for next-generation health, environmental, and energy applications. Research takes place in the 2 Swiss Federal Institutes of Technology, universities, research and innovation centers, and with industrial partners.
We always put together teams of people with different competence.
This multidisciplinary approach brings forward new innovative concepts.
And all this requires a very cohesive approach where several labs work together to achieve the common objective.
A global solution is achieved by orchestrating the various components into systems.
This 9-year program, which began in 2008, is now entering its 2nd phase and continues to build on previous achievements while exploring new directions. Phase 1 of Nano-Tera gave researchers new tools to monitor health and protect the environment. Developed on a tera scale, these complex systems exploit energy-efficient electronics on a small nanoscale.
Nano-Tera wants to make permanent and positive changes.
We can and we do actively contribute to quite a number of projects in Nano-Tera.
Nano-Tera strives at achieving demonstrators of the existing technologies within realistic constraints.
The 2nd phase of Nano-Tera focuses even more on improving healthcare in collaboration with hospitals and medical researchers to develop next-generation healthcare applications. Cochlear implants allow the deaf or severely hearing impaired to hear again. The Hear Restore project is an advanced medical imaging and precise robotic system for safer, less invasive, and more comfortable surgery.
The Flusitex project is a project where we develop a smart bandage, giving us an indication how the climate underneath the bandage is. And then if something happens, that will be detected by a camera system. We try to get this period where when do we have to change, when don't we have to change. By applying this smart bandage, we can maybe leave it 1 or 2 days. And then if something happens, we would see, oh, wait a minute, we know when we have to change.
We're exploring how to restore locomotion after spinal cord injury. The goal is to be able to stimulate both electrically and chemically the portion of the spinal cord that is below the site of injury, and then enable to awake the spinal tissue. We found that we could have a very good biointegration of the implant that is also capable of delivering electrical stimulation and drugs. The long-term goal is to be able to provide a technology for patients who are paralyzed so that they can indeed recover function of their limbs.
The Ultrasound to Go project is extremely ambitious because it wants to create a technology and a system that does not exist today.
So Ultrasound to Go is about creating a new 3D ultrasound imaging device.
And you could get a real-time image of how the heart is beating.
3D imagers have the advantage that even a non-trained specialist can already understand the content of the image.
It would be an enormous step in terms of diagnostic capabilities and in terms of saving lives and helping people in emergency situations.
What is important to achieve is a full chain of data in order to provide a service to the patient.
So partly C1 was to develop a diagnostic tool for cancer. So actually we have to touch the cells of the biopsy.
We use an atomic force microscope which employs a very sharp probe that directly touches the cells.
So instead of using only one probe, we use now an array, and by that we can reduce the time for the diagnosis from 2 hours to several minutes.
Today we know that we are limited in the amount of energy that we can spend. We have to deal with large-scale information. At the same time, we want to process this information with the least amount of energy.
Jeans is a very good example of a Nano-Tera project because it includes redesigning all the hardware components that are at the nano scale, processors, memories, cooling systems, all the way up to provide services for large amounts of people at the Tera scale. And we put these two things together, the Tera part of the applications plus the nano part of the hardware on the servers.
SHINE is a project where the goal is to develop methodologies to cost-effectively produce hydrogen from sunlight and water. Hydrogen is an interesting gas because it comes from water. It's very abundant on Earth. And secondly, it has a very high energy density. That energy density is very important for any mobile applications because you need to have high energy in a very small mass. So electric cars are interesting because it's a possibility to get away from fossil fuels. Now if you replace some of these batteries with hydrogen fuel cells and hydrogen tanks, then you can lower by about a factor of 5 the weight of the batteries.
Nano-Tera brings together researchers working to preserve the environment for future generations. Nano-Tera researchers have deployed monitoring systems in the Alps with the X-Sense project, whose goal is to understand mountain morphology and to anticipate dangerous events. The OpenSense project monitors air quality in cities dynamically and in real time. This research, funded by Nano-Tera, combines low-energy sensors with wireless communication systems on public transportation.
The Enviro project is actually focused on developing an automated system, a robot, that would integrate biological sensors. It will be totally something new if you think about having autonomous systems that can decide for themselves where they are going to look for specific pollution.
We want to really go smoothly through the water, detect the pollutant and find where it's coming from without mixing it up.
If you have a robot like we envision that goes near the surface, then you can imagine that you can still transmit data to a monitoring station.
So we designed this robot to be very portable. You can put it in a backpack, go to a lake or a river that's hard to reach by car, just drop it in the water, do your mission, collect the pollutant and go home.
We think that the migration of ideas from the research community to the economy will work mainly through the PhD students. These are the main product of our research.
I had the opportunity to come here from Turin to work for the Ironic project. This is the device that I built during my PhD. Imagine a patient that is in an intensive care unit. By putting this device in contact with the blood of this patient, you can monitor in real time some vital parameters and help the doctor that will read with a smartphone.
Nano-Tera has demonstrated the capability of developing advanced research ideas into demonstrators. We expect in the year to come to have a tighter integration between researchers and innovators in Switzerland so that we can provide a bridge to creating a better and brighter future.
Nano-Tera, small technology making a big impact.